An object with a mass of 1 kilogram tied to a string is doing circular motion with radius 8 meters on a smooth table at a speed of 5 meters per second, as shown in the figure below. The string is now pulled in until the radius becomes 6 meters. The tension in the string now becomes 2.37 times greater. What is the new circular motion speed of the object? So let's first draw a free body diagram of this mass. So this dot represents the mass. It's sitting on a table, which is smooth, so there's no friction. We have the normal force and the force of gravity that cancel each other out. And then we also have to have it pointing inward. There is a force of tension in the rope to prevent it from flying out and leaving the circular motion. So now we can set up an equation. The initial tension, before anything has changed, is simply the mass times acceleration. And the acceleration is towards the center of the circle. And this is, you might remember this as the centripetal acceleration. And now the centripetal acceleration is equal to the velocity squared divided by the radius of the object. So velocity squared over the radius. And now we can substitute this back in. The tension is equal to the mass times the velocity squared divided by the radius. And that is the initial tension. And then the final tension, or the tension after the change is made, is still given by this equation. But we also know that the final tension is 2.37 times greater than the initial tension. So now we can just substitute everything in. M mass times velocity squared divided by the radius is equal to 2.37 times mass times the initial velocity squared divided by the initial radius squared. So you notice again that the masses will cancel. So you get that the velocity squared divided by r is equal to 2.37 times the initial velocity squared divided by the radius. There is not supposed to be a square there. So I'm going to erase this, and we're going to move this to the top so that we have more room. This is the same equation as before. Just writing it up there. Alright, so now we just need to solve this equation for the final velocity, the new circular motion. So we can just multiply both sides by r and square root it. So we get the final expression that the new circular velocity is equal to the square root of 2.37 times the radius divided by the initial radius times the initial velocity. Now this initial velocity just gets square rooted, so it can get moved out. So now we just need to plug all the numbers in. So square root of 2.37 times the original radius of 8 meters divided by the new radius of 6 meters. This times the new radius of 6 meters, it's r, divided by the initial radius of 8 meters times the initial velocity of 5 meters per second. And now if you solve this, you should get that the velocity, the new circular velocity of the object, is about 6.7 meters per second. And that is how you would solve this problem.